Hey, this is Mr. Ward, and I'm going to talk about a new form of the equation for a line. It's called the intercept form. So here we go. The intercept. Oops, let's get that. Intercept form. Okay, the intercept form, very creatively named because it uses the x and y intercepts. So let's pick an x-intercept. Let's say 3, 0. There's my x-intercept, and I'll pick a y-intercept at 0, 2. Okay, now, so if x were at the x-intercept, then, if I had a line that was at the x-intercept, so I'd draw a line here. So there's a line. I'm going to draw a line through those two intercepts, okay? So here's the neat thing. Right here at this point, x equals 0, right? And y equals 2. Okay, just take note of that. And right here, x equals 3 and y equals 0, right? Okay. So here's what I'd like us to consider. What would x be? What would x over x equal at the x-intercept? X over x would equal 3 over 3, right? And y over y would equal 0 over, well, I should say, let's say x over the x-intercept. X over the x-intercept, well, x is 3, and the x-intercept is 3. So at the x-intercept, x is 3, so we're saying 3 over 3. But how about at the y-intercept? Y over the y-intercept. Well, the y-intercept is 2, but at the x-intercept, y is 0. So we would say 0 over 2. And that equals 1. And fairly straightforward, 3 over 3 equals 1. Let's switch the situation. Let's go over to the y-intercept, okay? And let's see what x over the x-intercept and y over the y-intercept equal there. Well, x at the y-intercept is 0, so over the x-intercept would be 3. And then y at the y-intercept is 2, so I'll plug in a 2. And the y-intercept is 2, and once again, I get 1. It turns out that we can generalize this for any x and y value. So I can replace x here, the 3 value, with a variable, and I can replace this y value with a variable for y, and that sum, x over the x-intercept for this line plus y over the y-intercept for this line will always equal 1. And now I've created a line equation for, let me clear all that green out of there so you can see the line. Pardon me. So I've now created an equation for a line that goes through an x-intercept at 3 and a y-intercept at 2. So this has some pretty cool implications. I can create an equation if I know the x and y intercepts pretty easily. I can say x over, let's say I want an x-intercept at -4. I'd say x over -4. Okay, and then let's say I want a y-intercept at 3. So I'll say plus arc in here, so it's hard to see the keyboard. Y over, get that where it needs to go. Y over 3. And I have done something weird in the formatting, so let me figure out where it is. You restart all of that. So what I want is an equation of x over -4. So I've turned the light off in my room where I'm working. This is the issue. Y over 3. I forgot to add the equals 1. Wherever this line is, x over the x-intercept plus y over the y-intercept will always equal 1. And we can test that out. We can take a look at points along this. So like here I've got Let me clear all that drawing out because it's in the way now. Okay, so every point on this, the y over negative 4 over x over 3 will end up equaling 1. So this is fairly straightforward. Here at negative 4 is 0, because negative 4 over negative 4 is 1, and 0 over 3 is 0, so 1 plus 0 is 3. And same thing here at 0, 3. 0 over negative 4 is 0, and 3 over 3 is 1. 0 plus 3 is 1. But what about other places? Well, if you work it out, if you take this value, these values, negative, let's say negative 2 over negative 4, that's the x value. That's going to be 1/2. And 1.5 over 3, if y were 1.5, 1.5 over 3 is also 1/2. So we got 1/2 plus 1/2. So that works out very nicely. So this form is generalized as x over a, which we often use in linear equations as the x-intercept, plus y over b, and there it is, b. And then so I've got x over the x-intercept, which is represented by a, plus y over the y-intercept, which is represented by b, and that will always equal 1. So now I'm going to create general points here. So notice that when I clicked add all for the sliders, it gave me a value of a equals 1 and a value of b equals 1. So this now is a line that goes through 0, 1, and 1, 0. So that's my x-intercept, that's my y-intercept. If I were to change the value of the x-intercept, it moves my x-intercept out to a new place. Now it's at 3.4. If I change the value of my y-intercept, it moves it to a new place as well. So now it's at negative 2.3. I can click on that. That is definitely negative 2.3. And I'll go ahead and make points. I'll make a point that is a comma 0. And another point that's 0 comma b. So I've created an x-intercept at a and a y-intercept at b. So I'll even put that down there. And now we'll press play and see what happens with that line. Okay, that line will stay with those x and y-intercepts wherever they are. The only issue that might come up is if they go through the origin, at which point you're having some 0 over 0 stuff, and then it's undefined. But this will work everywhere for lines that do not go through the origin. X over the x-intercept plus y over the y-intercept. Now, there is a laser cannon battle commander that you might be working with. So for that, I have put y-intercepts and x-intercepts. So I've put Blargian ships coming at the Earth from places on the x-axis. So I'll put a few of those down here. And let's say I have 2, 0, 5, 0, negative 8, no, let's say negative 9, 0, because that's what my finger hit. So I've got those points. I'll make them green so they're Blargian, so you can see what you need to do with those. Okay, and then we'll put some y-intercepts on as well. And the y-intercepts are the Earth ships. So 0, comma 5, we'll make it 6. So this little differentiation. And 0, comma negative 8. And 0, comma, we'll say 4. Okay, so there are some points that you can use. I'll turn all this other stuff off so it's not distracting. So the Earth will be at 0, 0, and then you've got these Blargian ships on the x-axis and blue Earth defenders on the y-axis. And they're all trying to come after the Earth at 0, 0. So I'll put an Earth at 0, 0. X squared plus y squared is less than or equal to the square of the radius that I want. So I'll call that 2.25. Make that a little smaller. Make that 1.44. And we will make that blue. For the Earth is mostly blue. So there's the Earth. And your job is to shoot this Blargian, this Blargian, and this Blargian from these ships. That's in the first part of that laser cannon battle commander. So to do that, okay, let's consider these points. I'll label the points to make it a little easier to see what they are. So I'll shoot from 6, 0. I'll shoot these 3 points from there. So I just have to say an x-intercept of -9 plus a y-intercept is going to be at 6 equals 1. And then, of course, I can make it fancy. I'll just say -9 is the low value for x is less than or equal to x is less than or equal to 0. And there I've made it fancy. Stretch that out so you can actually see the whole equation. There it is. And to make my life easier, I'm just going to copy pasta. So I already have a y-intercept at 6, so I will now go after the Blargian at 2. And I've got to change my inequality to be 0 is less than or equal to x is less than or equal to 2. And then I'll copy pasta that again, and I'll target this one at 5. Okay, so x is 5. Okay, and now I need to change my inequality again. 0 is less than or equal to x is less than or equal to 5. And that hits that one. And I could also hit it from the one below. So let's go down there. So instead of y is 6, we'll say y is -8. And now we've got one working for that as well. I'm going to copy pasta that. And now I'll hit the other 2. So I want to hit the one that's at 2. So x over 2. And I got to change my inequality again. So 0 is less than or equal to x is less than or equal to 2. That works. And then one more. I'll target the one that's at 5. X over 5. And the line's pointing in the wrong direction, so I've got to rearrange my inequality. So 0 is less than or equal to x is less than or equal to 5. And there I have it. I've shot all of the ships. Now, the last thing you're going to need to, the other things you're going to need to do are you're going to need to build shields around the Earth. So you can build shields by connecting lots of dots to each other. And then there's going to be a Blargian Death Star and a couple other Blargian ships that you will need to use any form of equation. Pi point slope form will be useful for you to capture. So hopefully you've got point slope form under your belt as well. Now I'm going to stop this video. I'm going to do a second one on how to convert different forms into the intercept form.